Alright, so last time we were talking about radicals and how we're going to solve these quadratic equations using radicals. So last time we had talked about simplifying radicals, and we had these two conditions. We said that no radicand has a perfect square factor other than 1, and that's sort of what example 1 is going through. So today we're going to focus on this second criteria that says that there is no radical in the denominator. So if we look at example 2 here, we're going to rationalize denominators of fractions. So what it means to rationalize is that you're going to multiply this fraction by another fraction to get the radical out of the bottom. And I have this table here to the side, and basically all this is saying is if you're in this part right here, if the bottom of your fraction looks like that, then you're going to multiply both the top and the bottom by that. If the bottom looks something like this, then you'll multiply the top and the bottom by that, and so on. So notice the difference for the second and third row is that if you have a positive here, you'll multiply it with a negative and so on. So let's look at what those look like. So for part A here, I want to simplify the square root of 5 over 2. So remember, you can always split this into the square root of 5 over the square root of 2. And then that table says, okay, which form is our denominator in? In this case, it's in the first one. So I want to multiply this by the square root of 2 over the square root of 2. It's important that you multiply it by the same thing in the fraction and the top as in the bottom because we're essentially multiplying it by 1. So what happens here is that, remember, we can combine these. We can make this 5 over 2, and we can make this the square root of 2 times 2. But the whole part about square roots is that if you have a double of something, you can pull it out. And hopefully you can see that 2 times 2 would be 4. So this would be the same as the square root of 10 over the square root of 4, or just square root of 10 over 2. As a shortcut, just know that if you multiply radicals that look exactly the same, you're just going to have whatever's on the inside as your final answer. So those ones are the most straightforward ones. If we look at part B, this one's a little more complicated. Now we're in this second row. Our form here is this a plus square root of b, which means we're going to multiply by a minus square root of b. So what that looks like is it would be 7 minus the square root of 2 over 7 minus square root of 2. So when you multiply these, make sure you multiply all the way through. And this bottom part, I'm going to multiply it all the way through this one time, but you're going to see that you'll have some things that will always cancel out. So for the top, when I multiply this, I'll have 21 minus 3 square root of 2 over, and on my bottom, I'll have 7 times 7, which is 49, 7 times negative square root of 2, so negative square root of 2. Positive square root of 2 times 7 would be a plus 7 square root of 2. And then finally, just like before, I have square root of 2 times a negative square root of 2, so minus 2 times 2 under 1 square root. So the top, really nothing's going to happen there, but notice in the bottom part, this middle term is always going to cancel out. So what you'll have is 21 minus 3 square root of 2 over, and this would be 49, and then this last part would be just minus 2. Because 2 times 2 is 4, so when you take that square root, you just have a 2. So the final simplified answer here is 21 minus 3 square root of 2 over 47. Now, as it's a fraction, we would check to make sure that there's no common factors between the top and the bottom, and in this case, there are not. So this is our final answer. If we look at part C, this is similar to the first example again. So we're in that top row, so really I want to just multiply this by square root of 15 over square root of 15. So I would have 2 times 15 over just a 15 on the bottom. So this would leave me with the square root of 30 over 15. Real quick, remember you want to check and make sure that you don't have any you don't have any perfect squares that divide anything under the square root. So just check really quick, 30 divided by 9, it's not divisible. 30 divided by 16, not divisible. 30 divided by 25, not divisible, you're good. So then this is your final answer. The last one again, this is now in our bottom row. It's a minus square root of b. So we're going to multiply it in the form of a plus square root of b. So that would look like 5 plus square root of 2. 5 plus square root of 2. So when you multiply these, I'm going to tell you, and this I will never say again, but you can skip this step. You can just multiply your last terms and your first terms, and you don't have to do the full FOIL for these, because that middle term will truly always cancel out. So in this case, you'd have 20 plus 4 square root of 2 over 5 times 5 would be 25. Negative square root of 2 times a positive square root of 2 would be minus 2. So this would simplify to be 20 plus 4 root 2 over 23. Again, you want to check and make sure that there's no common factors between the top and the bottom. 23 is prime, so there are not. So this is your final answer. So that's rationalizing the denominator, which we'll be doing in the worksheet today. And then I just want to remind you about simplifying these. So remember, we can still simplify these fractions. So if you look under example 1, we had skipped 2. So just to refresh your memory, simplifying these without the rationalizing part, you can recombine these. And then to the side, you want to figure out which perfect square they're divisible by. So 150 is actually divisible by 25 and 6. So this is the thing where we said, okay, we could write this as the square root of 25 times the square root of 6, which would leave us with 5 root 6. Likewise for part H, we could think of this as, as the square root of 15 times the square root of 4, and we know that the square root of 4 is 2, so we're left with the square root of 15 over 2. All right, so just a reminder, those are the two things that we need to be able to do to simplify these radicals.